Okay, so we're given this quadrilateral, we're going to analyze it and see if it has any special properties. To do that, we need to find distances. So there are four sides we're going to be finding distances. We'll also be finding slopes and distances. We need to find both for SH, this line here, for HA, this line here, for AY, this one, and for SY, this one. So I need to organize my work clearly. So I'm going to start off with SH, and I need to find both things, slope and distance or length. So SH is a nice one because when I look at this, it's a vertical line, which means its slope is undefined. If it had been a horizontal line, I would say the slope was 0. This is a vertical line, so its slope is undefined. And when you've got a horizontal or a vertical line, you can just count spaces to find distance. 1, 2, 3, 4, 5 units long. So the distance would be 5 units long. So there's SH taken care of. Thank you very much. All right, moving on to our next line here, HA. Okay, for HA, I'm going to find slope. Now the slope I'm going to actually have to do a little bit of work for, but I'll just count rise over run. Before I do that, I'm going to note whether it's positive or negative. HA, as I walk from left to right, is going uphill, so it has a positive slope. If I do rise over run from this point to this point, I would need rise 1, 2, 3 spaces and run 1, 2, 3, 4 spaces. So 3 over 4 for my slope. To find the distance between HA, I need to use the distance formula or create a right triangle and use Pythagorean theorem. I'm going to go with the distance formula because we've shown you that fairly recently. The distance formula looks like this. You're going to need to get this memorized or at least get it into your packet so that you've got access to it. And what you need to know about the distance formula is that your x's go in the first parenthesis and your y's go in the second parenthesis. And it's like x1, x2, y1, y2, but it turns out that it doesn't matter what order you put your x's in or what order you put your y's in. So when I do it, I always subtract so that I end up with positive numbers because positive numbers are easier to deal with. So if I look at my two x's for h and a, it's 4 and 0. I'm going to do 4 minus 0 instead of 0 minus 4. Because in my mind, 4 minus 0 is easier than 0 minus 4. When I look at my y values for h and a, it's 8 and 5. So I could either do 5 minus 8 or 8 minus 5. I'm going to go 8 minus 5. Are you writing this down? Or else you've done it already? All right, let's simplify that. Any questions where I got those numbers from? I need to move my paper over a little bit. All right, 4 minus 0 is just 4. 8 minus 5 is 3. Sorry, that's a plus, not an equals. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And I know the square root of 25, it's 5. Now, when I see your work on a test, I'm going to look to see that you've at least got this much of it, or that you've set up a Pythagorean equation. If you're able to go from this straight to 5 because you're typing it into your calculator, I'm okay with that. So in other words, you're free to skip these 3 steps here if you need to, if you want to. But I need to at least see where you've set up your distance. If you just write 5, I can't accept that. All right, so our distance ended up being 5. Our slope was positive 3/4. Any questions on HA? We're moving on to AY. So when I do my slope for AY, I'm going to notice that from A to Y, if I'm moving from left to right, I'm going downhill. So my slope is going to be negative. And I don't need slope formula, I can just count rise over run. So from Y to A, I would rise 1, 2, 3, 4 and run 1, 2, 3. So 4 over 3. So my slope is negative 4 over 3 from A to Y. What are you trying to say? We're working right here now. All right, now we got to find our distance from A to Y. So we'll use our distance formula. And I just need to plug in my x coordinates into this parenthesis, y coordinates into this parenthesis. So my x coordinates for A and Y were 4 and 7. I'm going to go 7 minus 4. My y coordinates were 8 and 4. I'm going to go 8 minus 4. Again, those are my 2 x coordinates and my 2 y coordinates is where I'm getting those. So we'll go ahead and simplify that. I'm going to do a little shortcut on this. I'm going to do some math in my head. 7 minus 4 is 3. And then I'm going to square that. 3 squared is 9. 8 minus 4 is 4. And I'm going to square that. 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. So we found a length of 5 again. That's 3 different segments, 3 different sides of this quadrilateral that all have the same length, 5, 5, and 5. So when we draw our conclusions at the end, I'll make sure that I talk about those 3 segments being congruent. Something else that I just noticed as I was doing this, these slopes are not the same. So these lines are not parallel, but look at the numbers. See how this is 3 over 4 and this is 4 over 3, they're just flipped. See how one's positive and one's negative? Those two lines are perpendicular, which means we are going to have a 90-degree angle. So when we do our conclusion, we'll keep in mind that we do have 2 perpendicular lines, which means we do have a 90-degree angle here. All right, we got one more segment to go. We've done SH, HA, and AY. We need to do SY now. From S to Y, as I'm walking from left to right, that's going uphill, so it's a positive slope. If I count my rise over run, I'm going up by 4 and over by 1, 2, 3, 4, 5, 6, 7. So 4 over 7 for my slope. That doesn't match any of the other slopes that I came up with. So it's not parallel to anything. It's also not the reciprocal or opposite of anything. So we don't have any perpendicular there. Let's find our distance and see if the distance matches any of our other distances. So x coordinates go here, y coordinates go here. My x coordinates were 7 and 0. My y coordinates were 4 and 0. So that ends up being 49 plus 16, that's 65. And that's going to be my distance. So I could type that into a calculator and get 8.1 as a rounded decimal. The big thing that I need you to know is special properties for this. Since SH, HA, and AY all have the same length of 5, those are congruent. Since these 2 slopes for HA and AY were perpendicular, opposite reciprocals, then we've got a 90-degree angle, a right angle at angle A. All right, we'll keep practicing this before our test, but you're going to need to be able to pull this off on a test in about a week and a half.